afternoon, evening, everyone. Welcome to our Rockets Away. We're getting closer to our last one, so welcome back. Thanks for joining in, and we're going to get started here. So, do you remember what we do first? We do some welcomes. So, again, my name is Brian McNeil. I'm an extension educator, and I work in our Southwest region. If you know where Morris is, that's where my office, and I do a lot of STEM programming, anything with robotics, engineering and design, and even aerospace, kind of dabble in that a little bit. And I'll turn it over to Sam.
I am Sam Jens. I'm the extension educator out of Lyon County, and I do a lot of STEM programming during the after-school program.
And if you all remember, every time we've been talking about this mystery person, and she's on with us tonight. So I'm going to turn it over to Suzanne to introduce herself.
Hello, everybody. I'm Suzanne Souza. I'm the extension educator in Big Stone County. I'm recognizing some of the names on some other programs I've been able to do. I've been busy with Tasty Tuesdays and teaching about amphibians. So that's why I get to finally join you guys tonight. So I'm excited to show you a little bit about the Alka-Seltzer rockets.
All right. Thanks, Suzanne, and welcome. Good to have you part of the team tonight. So now tonight, we're getting close to the bottom of our box. If you find in your kit the film canister, and I don't know if you didn't have Alka-Seltzer tablets, hopefully you were able to get some this week for our activity tonight. The other two things that are really important to have are water and paper towels, because this will be a messy activity. One of my favorite ones, just because we can make a nice little mess. All right, before we go on to our next thing, did anybody watch the news this week and see, or let's see, last week, and see what happened? Anybody watch the news or maybe talk to their parents and saw what happened last week? It has something to do with rockets.
Something made a really big bang.
Yes, it did. Any guesses? I think it was about Tuesday, Wednesday.
It blew up.
What? Yep, you're right, Nathan. What blew up?
The rocket, I think.
Do you know what it was called? The name of it?
No.
Tyler and Isaiah said the SpaceX rocket blew up.
The SpaceX rocket. Now, does anybody know what their intent, once they get that finalized, what they want to do with that big of, this is one of the biggest rockets they've sent up, what they hope to do with that? They want to get back to the moon, create a space station on the moon, and create another launch site. So they're really excited that that big of rocket, even though it blew up, that it got up in the air as high as it did, because they can start working on that size of rocket and working to get back to the moon to create this little space station that could be another launch site to launch rockets further into space. So
And
maybe, go ahead, Sam.
I was going to say, just for reference too, they blew the rocket up on purpose. It wasn't on accident.
So maybe in your lifetime, some of you might see this happen, might see where they actually create this space station on the moon and actually project rockets further into space. That would be cool. All right, now I know Suzanne's just busting. She's actually popping. She's actually bursting, ready to go with this activity. Can I think of anything else, Suzanne, that kind of blows up? Bursting, popping, exploding?
That's all I can think of. So,
okay, so
first,
I'm going to turn it over to Suzanne, and she's going to talk to us a little bit about this activity tonight.
all right. So from what I've been understanding, that you guys have been learning a lot about rockets the last few weeks. Is anybody that wants to share a couple things that you've learned so far? You can unmute yourself. I know you've learned something.
Force.
Force. What about force?
how when rockets or airplanes fly, like the blasters or the air pushes it up into the air, and that force makes it fly and pushes it into the air. And we did that with the ping pong balls and the blow dryer.
Very good. And then I see in the chat that mass is, let's see, we got masses rule. Anybody else have anything they want to share that they learned so far? All right, if not, we're going to just go on and learn about Sir Isaac Newton. He's done so much, hasn't he, to help us with our mass and force and everything. So we've got Newton's laws, and right now we're going to be going through Newton's second law, which is the greater the mass of an object, the more force will take to accelerate the object. And we're going to see that tonight in our demonstration, okay? And then Newton's third law is for every action, there is an equal and opposite reaction. Who can tell me what they think that means? How many of you have been studying Newton's laws already? All right, well, we're going to learn a little bit more. So, Ryan, do you have another slide for this one? Okay, so we're going to talk a little bit more about the activity. So like Brian and Sam said earlier, we've got our film canister. All right, everybody should have had one in their box. Okay, then we have some Alka-Seltzer. Who knows what Alka-Seltzer is? Anybody ever hear of Alka-Seltzer before? All right, well, of course, it's going to help us with our experiment tonight, and I'll share a little bit with you about that. So what we're going to do is I'm going to head outside because I'm not going to have this explode in my house, because knowing me, it's probably going to hit the top of the ceiling and I'll have Alka-Seltzer all over the place. Who's excited to do this? All right.
What did you just say? Go outside?
I'm going outside. You can stay in your house. You got to ask your mom and dad if it's okay if you can do this in the house, though. And one of the things too, if you have them, or if you ever do this experiment, always think about how can we protect our eyes when we're doing experiments like this. That could be powerful. If you have any safety glasses around, you can always wear safety glasses too. I've got my glasses on, so when we do this experiment, I don't want you to put your face down by it or anything. You're going to stand away from it, okay? All right, so what I'm going to do is going to open up my canister right now. I think I am going to try it in here. And then I'm going to fill it. I have some water right here. And I'm going to fill my film canister halfway with water, okay? Then I'm going to take my film canister out. I'm going to take my Alka-Seltzer tablet out, and this is what they look like. It's just a tablet, okay? All right. And you might not see a pop, but hopefully you will. So we're going to drop this into our film canister. We're going to put the lid on it, and then there's two different ways you can do it. Some people do it with the lid up, but I'm going to show you, I'm going to flip mine around really quick and put with the lid on and see what happens, okay?
Do you put the whole thing in?
Did you hear that? Did anybody hear the pop? All right, mine popped and went up. Okay, so let's everybody try this again. You can do it two ways. You can do it upwards like this, put your Alka-Seltzer in there and walk away from it really quick and it should pop up in the air.
Mine's not popping, but there's bubbles that are literally lifting, but it's going straight back down.
It's okay. Sometimes it's just can be a little bit of a fluke. It's always one. Sometimes with science, we have what's called trial and error. So try it again. Okay.
And make sure the cap is really tight.
Yeah, because if it's loose a little bit, what's going to happen is that water is going to leak out. And we don't want that to happen. Okay.
Suzanne, I heard somebody ask, do you put the whole tablet in or do you break it up?
I have put the half tablet in sometimes, and I put the whole tablet in, just depending on how impatient I am. I want to see it go up in the air, but you can break it in half. Let's try this again. I'm going to put mine up first.
Ooh, Tyler and Isaiah are trying it with baking soda and citric acid.
And that's, you can use that too. And see, was it Nathaniel? Did you say yours was just sizzling? There went mine. So mine seemed to work better when I flip it over. And if you do this outside, you can get these going quite a few feet up in the air. Has anybody gotten a chance to get theirs to go in the air yet?
Yes.
And sometimes what makes it work too is you don't really want to use real cold water. You want that water to be a little warm so that tablet starts breaking down. And who can tell me? Oh, okay. Very good, Tristan. Yours popped like a foot in the air. Good. And sometimes you can get those going pretty far up. So who can tell me why this canister with an Alka-Seltzer tablet can pop up in the air like that? We're thinking science right now. We got a chemical reaction going. So what do you think is in the Alka-Seltzer tablet that's making this canister pop up in the air? Hannah and Tristan, go ahead and answer. Your hands up. I think they want us to see their experiment. You're still, Hannah, you're muted. All right. So if anybody can share with me what chemical reaction is happening. Sounds like Hannah and Tristan are having fun out whatever they're doing right now because they're all over the place.
If you look at Tyler and Isaiah's, they have dancing lids. Those lids are bubbling up on theirs.
Very good.
Matthew said that there's sodium bicarbonate in the Alka-Seltzer tablet.
Very good. So in that sodium bicarbonate, what's happening is when we add that water to that film canister with that Alka-Seltzer tablet, the carbon dioxide is released, which builds that pressure up inside of that canister. When there's enough pressure that builds up, it blows the canister apart from its lid. That's like launching a rocket into space. So it's kind of the same concept with rockets. We've got that buildup of carbon dioxide from the calcium bicarbonate, and there's that chemical reaction happening as soon as we pour that water in. Or is there any questions?
Yes.
Okay.
Why do the Alka-Seltzer slits Why do the tablets explode in the water?
Because as soon as when that tablet hits water, it's releasing that chemical in that tablet. There's atoms that are kind of just, they're reacting with the water and they're building up in the pressure because of the pressure in there. So that's why it's bubbling like that. Alka-Seltzer, if you don't know what it is, Alka-Seltzer is actually a medicine that helps people.
Oh, I hit the ceiling.
Oh, yours hit the ceiling? Awesome. It's a medication that people have used over the past if they had upset stomachs. So, well, we've got some excited kids right now because it's working for them. So, like I said, those bubbles are happening and they're breaking down. And Alka-Seltzer, when we have a lot of, some of you guys get tummy aches or anything like that, sometimes you hear your stomach gurgling and bubbling. This was a medicine that a lot of people use for a chemical reaction to get that bubbling to stop and go away. So that's what it is calcium bicarbonate in there. But this is an adults take this, not youth. So don't try it at home, everything. So otherwise, who had one that went really high up in the air?
We tried
Mine
it
did.
right side up, and the lid almost hit the ceiling.
Oh, very cool. Did it take you a couple times to do that, Nathaniel? To get it to go that high?
The first few times we didn't seal the lid on tight enough.
Yep, and that'll happen. Did you notice the water leaking out because you didn't have the lid on tight?
I had an amazing explosion.
Yep, that's what happened to mine. I didn't put the lid on tight enough and the water started leaking out when I flipped it over.
Ours was pretty cool because mine, like, both of ours, the first time my sister did it, it hit the ceiling. Mine didn't hit the ceiling. It like flew all the way across the outside railing into the grass. And then my brother's, the second time he did it, it went and landed on the roof. And then it bounced off and down.
What do you think between you two, what do you think you did different to make yours go one direction and the other go up? What do you think?
I think mine, because I put a full tablet in there, and also because first I sealed it on not tightly enough, and then I saw bubbles, and then I pushed it down, and then I left it alone, and then it just fizzed because I sealed it on tighter. So I had a lot more pressure. And then for Tristan's, I think full tablet too. I think what happened is he pushed it down really hard, so then it let out a lot of pressure.
Very good. Anyone else want to share about theirs? Do you think that if you added less water made a difference, or if you added more water? Did everyone add less than a half of water? Okay, good.
We added half and then a whole tablet.
Okay, so you did less than half and then a whole tablet. All right. Anything else you'd like to share? What'd you think of the experiment? Tristan says he added a little bit more water. So do you think adding that water made it go further up in the air than, or did it not go as far up when you added more water?
It didn't go as far up because I'm pretty sure that there was less room for more pressure inside of the canister, so it would go less farther up.
Okay. So when you think about that cap popping off of the canister, how do you think this kind of is similar to a rocket engine? How would this be similar to a rocket engine?
Because a rocket, when the thrusters are getting that liquid in there, and then there's a lot of pressure, and then when they're ready they launch, and then all that pressure releases.
Very good. Yes, it does need a lot of pressure to go off. Okay.
And just like the tablets, when we put the tablets in the liquid, which is like the oil, it explodes like when the rocket is ready to launch.
yes.
Oh my word, I licked this stuff and it's making my shirt go out of control. Are we muted?
So I heard a lot of things tonight about how we did some changes. You know, we added a little bit more water, didn't add as much water. We added half a tablet, we added a full tablet. So the one good thing with science is that it gives us a lot of time to experiment, but we always want to make sure that when something calls for directions on how to do it, that if we want to change it up, we do it slowly. So we make sure that we're not having any other different types of chemical reactions that we don't need. So can some of you name some other chemical reactions that happen? Have you ever put anything else together and got a chemical reaction?
We did a volcano.
Okay.
Together with our friends.
Okay, what are the two things we use to make volcanoes erupt?
Baking soda and what else? Water.
Yes, that's baking soda and water. What's another chemical reaction?
Explosions.
Have you ever made bread before?
Yes, we actually read a whole bread book about it and made multiple things of bread, even pretzels.
And so there's a chemical reaction happening with bread. What do you think the reaction's happening?
The yeast.
Very good. Very good. So when we add the oil and the flour and the yeast to the bread and we mix with the water and stuff, it looks like we have a small loaf of bread, but then over time, what's happening? Before you can bake it, something's happening and the yeast is causing a chemical reaction. What's happening to your bread loaf? Is it getting smaller or is it rising?
It's rising.
All right, very good. Very good. So that's another chemical reaction right there. Any other chemical reactions you've seen? So there's some chemical reactions you can do with food coloring and oil. How many of you ever made a lava lamp before? Where you put water and cooking oil in there, and there is a reaction going there. And if you put food coloring in there, and you could add an Alka-Seltzer tablet to that. Have you seen a lava lamp before? How it dances around? You could try this at home too. So that's another chemical reaction with Alka-Seltzer with the bicarbonate. It'll make you saw how the bubbles were in the canister and the bubbles were building up. If you ever look up a lava lamp experiment to do at home, you can do this in a canning jar and you can put water, cooking oil, some food coloring, and an Alka-Seltzer tablet in that, and you'll see the water and oil bouncing around in there and with different colors, okay? So there's all kinds of different chemical reactions that you can safely do at home with experiments and everything. So are there any questions?
Excuse me, can you tell me the things you use for the lava lamp again? I know water.
You use water and then like cooking oil, like Wesson oil or canola oil that your parents might have at home for cooking, but make sure you ask them first. Don't start mixing things. And
So just regular cooking oil?
yeah, And then you put some food coloring in there. And then you add an Alka-Seltzer to that and put the lid on and you'll see it moving all around.
Does it actually glow in the dark, or do you have to add glow in the dark stuff in that?
It kind of lights up a little bit because of the oil.
Okay.
You will
I can
see.
also add glow in the dark paint on it.
Yep. All right. Are there any more questions in regards to our Alka-Seltzer rocket?
Thank you, Suzanne, for leading the experiment tonight. So next time, like Suzanne said, we're going to be making the Gnome rocket, which I know many of you are like itching to get into that. So next time you're going to need your rocket out of your kit, and some things from home are like Elmer's glue. So if you have some Elmer's glue, we're going to need that. If you have your parents around, either a sharp knife, a razor blade, or something sharp. And so make sure to have a parent there to help you with that step. Scissors and a ruler, and probably a pencil too. So if you got Elmer's glue, something sharp, a scissor, a ruler, and a pencil, we're going to be making the rocket next week. And we may have to plan for a half hour, maybe 45 minutes. So we may go till about 7:45, just depends on how long everybody hangs in there with the instructions. So just know that next time will be a half hour, if not 45 minutes, for us to build the rocket. All right. Any questions what we're doing next time?
So what place do you think we can meet up for next week? Because I don't think we're that busy, but I'll check with my mom.
Next week we're virtual again, so we're doing a virtual, but we are looking at doing an in-person launch site. And next week we'll talk about what that might look like. But next week we're going to do virtual again. All right.
But again, what does virtual mean?
That's what we're doing tonight. So technology, we're doing a Zoom land.
Okay.
So it'll be just like tonight, but next Monday night.
Okay.
You'll see us on the TV screen.
Okay.
Any other questions? So next time, have those pieces one more time. Elmer's glue, something sharp and apparent, a scissor, a ruler, and a pencil. All right, and your rocket. And we'll step-by-step build that, and then we will announce maybe 1 or 2 launch places that we're going to meet in a few weeks to actually launch these off. But we'll talk about that next time.
Bye.
All right, have a great evening. Thanks for joining.
Bye.
Bye.
See you next week for the launch.
Hey, Hannah and Tristan, are one of your parents around?